let's move on to the next concept from the chapter Lines and Triangles. So, what are triangles? A triangle is a basic geometric shape that has three sides and three angles. So, what comes into your mind when we think about a triangle? So, triangles have three sides, right? So, we have two lines and we have the third line joining them. Here we got three lines and we got three angles, right? So this a geometric shape which have three sides and three angles is called as a triangle. So what are sides and vertices? A triangle have three sides. We know, let's name the 3 points as A, B and C. So we have three sides AB, we have AC and we have BC, right? We have AB which is this side, we have AC which is this side, and we have BC, AC which is this side, and we have BC which is this side, right? So these are called the sides, and there are connecting points between them, right? That is, this is one point which connects AC and BC, this is a point which connects AC and AB, and this is a point which connects BC and AB, right? So these points or connecting points are called the vertex of a triangle or vertices of the triangle, right? Now angles. At each vertex of a triangle, you will find an angle. An angle is formed by two sides of triangles coming together. That is, when AB and AC is coming together, we have AB and AC coming together. Here comes an angle, right? When BC and AC is coming together, here is another angle. And when BC and AB are coming together, we get another angle. So, the three angles in a triangle always add up to 180 degrees. This is a very important point to notice. That is, the three angles in a triangle always adds up to 180 degrees. So, when we are adding the three angles here, let's name this angle X, Y and Z. When we are adding this X angle, X degrees plus Y degrees plus Z degrees is always equal to 180 degree. This is an important property of triangle. Now we could actually have some fun with these triangles. See, in this figure, this forms a huge triangle, right? So this angle, let's say, this angle right here, right, plus this angle right here, let's make it more evident, right? So we have an angle here, we have another angle here, and we have another angle here. Let's call it ABC angles. So angle A plus angle B plus angle C would always be equal to 180 degrees. Now if we take each of the triangles in here, right, in the same triangle too, I'm saying this is angle X and this is angle Y. This angle B plus angle X plus angle Y would also be equal to 180 degrees. Why? Because it's forming a triangle, right? Now, if I'm considering this triangle right here, the triangle which have a side like this, another side like this, another side like this. This angles in this triangle, let's name this angle as P and this angle as Q. If we are saying the angle C plus angle P plus angle Q would also be equal to 180 degrees. So no matter how small the triangle is or how large the triangle is, always the sum of three angles would be equal to 180 degrees. Now, let's talk about the different types of triangles, okay? So we could actually categorize triangles into different types according to their sides and also according to their angles, right? So we were talking about triangles, so let's see. So we have a triangle, we have three sides, AB, BC and AC, right? So we have three angles X, Y and Z. So we could actually categorize the triangles by according to sides and also according to the angle between them. So let's see how they're categorized according to the sides. First of all, it's a scalene triangle. What is a scalene triangle? Scalene triangle is a type of triangle that have three different sides of different lengths. In other words, none of the sides are equal to each other. So here, if this side, the length of this side, right? If we are naming this ABC again, AB, the length of AB would not be equal to AC and this won't be equal to BC. So none of the length of the sides of this triangle is equal. These type of triangle is called a scalene triangle. Okay. Now, isosceles triangle. Isosceles triangles are the triangles where their two sides are equal to each other, right? So, we have a triangle here. Again, let's name it PQR, right? So, the side PR and QR are equal. PR is equal to QR here, but PQ is not equal to them, right? So, this is an isosceles triangle. So, there is a very interesting property of isosceles triangle. Why? So, basically, we are saying that two lines are equal, right? This line and this line, and there is a common line in between them. Does it remind you of something? Like we have a common line and a common vertex, right? So what is it called? These are called, where we talked about edges and angles, right? So for edges and angles, we have a common vertex. We could consider this as common vertex. Why? Like these are not edges and angles, but it have a property of edges and angle. What is that? This angle and this angle would be same. How come? So we have a line here, right? We have one line crossing like this, another line crossing like this, and we are saying that these two lines are equal. This line is equal to this line. So the angle made by this line here and the angle made by this line here are equal, right? So in an isosceles triangle, two of these angles are also equal when the two of the sides are equal. Now, the last type of triangle which is classified according to the sides is equilateral triangle. So, equilateral triangle is a special kind of triangle and it has some unique properties. The word equilateral itself gives a clue about its characteristics, that is, all three sides are equal in this type of triangles. So, what does this imply? It says that all three sides are equal, right? So, when we said that in case of an isosceles triangle, two sides were equal and one of them was different. So, these two angles were equal and we had a different angle, right? In case of equilateral triangle, we have three sides equal, right? That means that all three angles are equal because all these lines are equal. Now, how did we get this angle as 60 degree though? We said that sum of all angles, let's say this was x degrees. Also, if this is x degrees, all three are x degrees, right? So, all these angles x and the next x and the next x adds up to 180 degrees. That is the basic property of triangle, right? So 3x is equal to 180 degrees. So what is the one of the angles of the triangle? It's 180 divided by 3, which is equal to 60 degrees. So 60 degrees is the angle between two sides of an equilateral triangle. Now, let's categorize the triangles according to their angles. So, we talked about acute angle, obtuse angle, like 90 degree, right angle, and then straight angle. We talked about reflex angle. We talked about different types of angles, right? Now, what is an acute angle triangle? So, acute angle triangle is a type of triangle where all three angles are less than 90 degrees, right? So, if all the angles of a triangle is less than 90 degree, it's called an acute angle triangle. So, is equilateral triangle an acute angle triangle? Yes, it is. Why? Because all the sides are 60 degrees. All the angles are 60 degrees in an equilateral triangle, right? And it is less than 90 degrees. So, we could say that acute angle triangles have an angles, like all the angles less than 90 degrees. Now, the next type of triangle is right angle triangle. So, what is a right angle triangle? The right angle triangle is a type of triangle that has one of its angles measured 90 degrees. So, we have three sides of a triangle here and one of the sides measures 90 degree. We call it a right angle triangle. And these triangles have some very interesting features to know about. So we talked about two types of triangle based on their angles. That is, one is acute angle triangle and the next one is right angle triangle. So right now we were talking about the right angle triangle, right? So here comes another right angle triangle. And here comes a very beautiful theorem called Pythagoras theorem. So Pythagoras was actually a Greek scientist. So he discovered this theorem saying that, in a right angle triangle, you see here three sides. So we have names for each side of a right angle triangle. So the side which is right opposite to the 90-degree is called the hypotenuse of the triangle, right? And now when we are considering the angle here, right, any one of the angle, the line which is closest to that angle is called adjacent angle, and the line which is opposite to that angle is called the opposite side, right? Now here in this triangle, let's find the hypotenuse, adjacent angle and the opposite angle. So the angle which is opposite to this, the side which is opposite to is called hypotenuse. Now if I'm considering an angle here, A is the adjacent side, right, and B is the opposite side, right? Now what does this Pythagoras theorem say? The Pythagoras theorem states that the square of hypotenuse is equal to the sum of square of the adjacent side and the opposite side. So what does it state? Let's say C square is the square of hypotenuse is equal to the sum of square of adjacent side and the opposite side, right? So here it is a very interesting figure to show how this is happening. So this square, if I'm taking A as one side and I'm drawing a square, right, the area of the square is A square and the area of this square is B square and the area of this square is C square. Now Pythagoras discovered that if we add up these two squares, the area of these two squares, we get the area of this square. Now it seems to be a very simple theorem, but it's used in a vast majority of cases when it comes to like science and like everything. So let's see some important terms related to triangles. So altitude. What is altitude? What does it remind you when you hear the term altitude? Altitude basically means the height of a thing. We say that, we are at an altitude which is this much meters above the sea level. What does it mean? It means that we are at a particular height above the sea level, right? Now, in a triangle, the altitude is a line segment drawn from one vertex, that is the corner of the triangle, perpendicular to the opposite side of the base. It is a line that goes straight up or down from one corner of the triangle to the opposite side, right? So we have to find the height of the triangle or altitude of the triangle. From the highest point, we draw a line to the midpoint of the other side. So this is called the altitude of the triangle. This is the altitude of the triangle. So what does the altitude does? If it actually divides the opposite side, right, into two different equal parts, that is the altitude. Now we have something called the median of the triangle. In a triangle, a median is a line segment that connects a vertex of the triangle to the midpoint of the opposite side. In simpler terms, you can think of a median as a line that starts from one corner of a triangle and goes to the middle of the opposite side. So when we were talking about altitude, we just said that it starts from this corner and it actually connects the middle point of the other side, right? It connects the middle point of the side to the vertex of this point. Now, what if we are taking this point or this vertex and we are drawing a line to the opposite side, to the midpoint of the opposite side? Now this is a median. The next median is this one, where we take the point B and we get a point E, which is the midpoint of AC, and we connect these two lines, and this is another median, right? This one is also a median, but it have a speciality, but it is called the altitude because it represents the height of the triangle. Now, incenter of a triangle. The incenter of a triangle is a special point that can be found inside the triangle. It's the point where the angle bisectors of the triangles intersect. So, we talked about bisector of an angle, right? We had an angle like this. We just draw a line which divides the angle into two different equal parts, that is called the bisector of a triangle. So what is in center of a triangle means? It means from one point we are drawing a bisector towards the other, right, other opposite side. Now from this vertex we are drawing another bisector of this angle towards the opposite side, and from this vertex we are drawing another line, right? So now all these three lines coincide at a point, right, this point I, and if we take this as the radius, right, from here and from here and from here, if we take this as a radius and draw a circle, this point is called the incenter of a triangle. This is the incenter of a triangle. Now we have circumcenter. In a triangle, the circumcenter is a special point that is equidistant from all three vertices of a triangle. In simpler term, it's a center point that is the same distance away from each corner of the triangle. In a triangle, the circumcenter is a special point that is equidistant from all three vertices of the triangle, and in simpler terms, it is the center point that is the same distance away from each corner of the triangle. Now this is actually the circumcenter of the triangle, right? And in center, where all the angle bisectors of the triangle intersect, this is the incenter. Now if we are taking a circle like this, here comes a circumcenter, right? If we draw a triangle inside, there would be a midpoint that is also called the circumcenter. Now let's talk about congruent triangles. So what does congruency means? So when we say that two triangles are congruent, it means that they are exactly the same in terms of shape, and it's like they are twins or clones of each other. If you were to compare the lengths of their sides and the measurement of the angle, you would find that they are exactly the same size. So here there are two triangles ABC and DEF. So how do we find the triangle is congruent? A triangle is congruent when, we have AB side which is same as DF side, right? We have angle ABC which is same as the angle EDF, right? So the congruent triangle means if I have a triangle and I place it somehow over the next triangle, right, we get the same triangle. We just see one triangle. Why? Because they both are equal, right? We are actually cloning the triangle and putting into the different thing. Now, there are different criteria to actually find out whether a triangle is congruent to another triangle. What does congruency means? It means that it's same. So there are different criterions to see whether a triangle is congruent to another triangle. So the first criterion is SSS congruency criterion. So what is SSS congruency criterion? SSS stands for the side, right? It means that if we have two triangles and all three sides of one triangle are equal in length to the corresponding three sides of the other triangle, then we can say that the triangles are congruent. Here see, there are two triangles here, ABC and PQR. We are saying that the length of AB is equal to the length of PC. Let's say AB is equal to PQ, right? And we are saying BC is equal to PR. BC is equal to PR, and we say that AC is equal to QR, right? So we have all three sides of the triangle equal to these three triangles, right? That is, if you are placing this side over here, that is, we are placing this side AC over QR, and then we could see that AB would be placed on PQ and BC would be placed on PR. Then it becomes the same triangle, right? So this is a criterion which says that when three sides of the triangle are equal to the three sides of another triangle, they are congruent triangles, they are similar triangles, right? Now, there is another criterion which is called the SAS congruence criteria. So SAS stands for side, angle, side. So what does it mean? That means that there are two sides which are equal to a triangle, and the angle between those two sides are also equal in these triangles. Then it means that these two triangles are congruent triangles. What does that mean? Here we could see that there is a side. Let's name this triangle PQR, and this is ABC, same. So here it is said that RQ the side RQ is equal to CB, right? Now, the side PQ is equal to AB, right? And what is the angle between PQ and RQ? This angle, let's call it X. And there is an angle between CB and AB, which is called Y. If X is also equal to Y, that is, we have two equal sides and one equal angle, which is in between of them, then we say that according to SAS congruence criterion, which means that side angle side criteria, we have two triangles as congruent triangles. Now, let's talk about ASA congruence criteria. ASA stands for angle side angle. It's a rule or criteria that helps determine if whether two triangles are congruent. But what is the criteria here? We have two equal angles. We have this angle equal to this angle and this angle equal to this angle. Let's name this angle XY and let's call this AB, right? So, there are two angles and we have one included side which is equal. Here, the angles are angle X equal to angle A and angle Y equal to angle B. Also, what is the included side here? AB equal to the included side XY. So, this is the ASA congruence criteria where two angles in one side, that is angle side angle. Here, an important thing to notice is that there is no point in this side, any other side, it won't become equal, but any other side becoming equal. The included side between the angles should be equal. That is why we put the side in middle of the angles, right? Now, the last criteria is the RHS congruence criteria. RHS stands for right angle, hypotenuse and side. What is RHS? Right angle, hypotenuse and side. It's not the right hand side of the equation, but it's right angle, hypotenuse and side, right? It refers to the three parts of the right triangle. A triangle with one angle measuring 90 degrees. The RHS criterion states that if two right angles have their hypotenuse and one of their other sides equal in length, then two triangles are congruent. If we are saying we have two triangles here, right? We have two triangles here. And we are saying the hypotenuse is the longest side which is opposite to the 90 degree. If the hypotenuse of these two triangles are equal and one of the sides are equal, right? If we are saying these two sides are equal and I'm also saying this side is also equal, then it is actually a congruent triangle. How did this happen? We know that according to Pythagoras theorem, if I'm saying, let's consider this triangle POQ, right? For triangle POQ, the side hypotenuse is PQ square, right? PQ square would be equal to OP square plus OQ square. Now, here in the next triangle POR, here PR square would be equal to PO square, that is OP square, plus OR square. Here PQ and PR is equal in length and OP is common for both. Even if it's not common, if it's equal to each other, the other side should be equal, right? How did this happen? Because OQ square would be equal to PQ square minus OP square, right? And OR square should be equal to PR square minus OP square. Here we said that PQ and PR are equal. So obviously this both would also be equal. This is the right angle, hypotenuse and side congruence criteria or the RHS congruence criteria. Now, this is a simple explanation of what are the four criterions for stating the congruence of a triangle. First is the side criteria, which is SSS criteria where all three sides are equal. Next is the SAS criteria where two sides and one included angle are equal. Next is the ASA or angle side angle criteria where two angles and one included side are equal. And another one is an RHS criteria where the hypotenuse and one of the side are equal. And these are the theorems or these are the properties of congruent triangles. So that is it about the chapter lines and triangles. In triangles, we talked about different things like types of triangles where we classified it according to the sides. We talked about scalene triangles, they have no equal sides. Then isosceles triangles which have two equal sides and equilateral triangle which have all equal sides. Then we talked about acute triangles which have every angle less than 90 degree And then we talked about right angle triangle, which have one angle 90 degree. We talked about Pythagoras theorem, where it states that the hypotenuse square is equal to the sum of adjacent side and the opposite side square. Then we talked about altitude. We talked about median, circumcenter and incenter of a triangle. Then we talked about congruent triangles, which are actually triangles which are similar to each other. Then we talked about the criteria for a triangle being congruent, for two triangles being congruent. First one was the SSS criteria, then SAS criteria, then ASA criteria and RHS criteria. This is all about the chapter lines and triangles.